Hello, my name is Alex from RPL Studio, and I'm going to start a series of tutorials about smoke simulations in Blender. I'm going to divide my tutorials in small parts, as I'm going to describe in details each parameter with examples. When we finish it, we are going to make some exercises that will reinforce what you have learned in practice. Later I'll switch to smoke and fire and liquid simulations after this. So let's start doing that. To create smoke in Blender we need to have two elements. First of all, we need to have domain. This is the area where we will be doing all calculations. So we'll be making calculations and all simulations only inside this area. This will help us to save some personal computer capacities and not to calculate everything around this, only inside of the box. This is our domain. And second moment that we need to have to create smoke is our emitter. Emitter can be any element, any object that you create, any mesh that you can have in scene. So right now we have this object. This will be emitter. So it's the source of the smoke. Let's make it scale. Okay, so how to make smoke working right now? First of all, we need to make Blender thinking that this cube is domain. How to do it? Let's go to Physics tab. Let's click Fluid button, and then from drop-down menu we need to choose Domain option. That's it. Our cube is domain now. Great. It's done on this stage, and for source we need to do the same. We need to say Blender that this is source for our smoke. So we click Fluid, then we should pick from drop-down menu Flow, and here we need to make some adjustments in these settings to make it working correctly. Later I'll explain every parameter here, but for now we will make just basic setup. So we choose flow type like smoke and flow behavior inflow. We have three options here: inflow, outflow and geometry. When we pick inflow, this means that our emitter will be emitting, our source will be emitting particles outside of the objects. If we pick outflow, it will make this object removing smoke that interact with this object, with bounding box of the object. And geometry, we will emit in one frame, we will emit smoke that will be equal to the shape of our object, and this smoke will be flying up in case of use only gravity, or if we have some directions or force, it will be flying to different sides, but only for one frame. Again, with examples we will take a look on this later. Right now we choose this inflow. That's what we need for our simulation. And let's start playing this simulation. That's it, it's working. But before we dive deeper into this, I want to pay your attention for some moments. So this will help us work better with this. So what we need to do? First of all, we can add light here. We can add sun. And when we add sun, our smoke will be interacting with this sun, and we will get some shadows, and it will be easier for us to work with this. But you can see that now nothing is happening. To make it working, we need to reset this simulation and recalculate everything inside of this domain. To do this, all you need to do to change any settings here. Usually I use this checkbox. I just disable it and enable again, and that's it. Our simulation is already resetted. Let's restart it again, and you can see that we already have some smoke with nice shadows, and it's looking much better in real time. We don't use any render stuff. So yeah, just for setup that will be enough. To make it looking even better, I want to make some other adjustments. Today I'm going to talk only about settings rollout or settings tab. All other tabs I'll be covering deeply later, but today I want to mention about moments that make it easier for us to work with this today. First of all, I want to add noise here. Noise will add some curling to our smoke. It will look a little bit more interesting more realistic. So yeah, let's use noise here. And sometimes for describing some options, I'll be using dissolve option. Dissolve option mean that when smoke is emitted, it disappears right now in 5 frames. So what it means? When particles are being emitted, they move up, and their life age is equal to 5. They die in 5 frames after they are being emitted. You can change, for example, to 2 and restart simulation. It will be like not very high smoke, and so on and so forth. So we will be using these options sometimes, changing time here. So just keep in mind, this other setup, this setting, these parameters we will discuss later in another tutorial. Another important moment is cache. Cache store information about your simulation. It writes information about each voxel in your domain to your drive or your memory. It creates temporarily folder where it saved information. This you can use replay type for preview purposes, but in case if you are going to finalize your animation, you should choose all type to make this baking. And I want to mention about one more moment that can be important for working with simulation is viewport display. We have few fields here. First of all, thickness. Thickness defines how dense is our smoke. If you make it 5, it will be more dense. Or if you make 10, it will be even more dense, so we can see more smoke. This is just for preview. It doesn't affect anyhow your final render, but for preview purposes you can use it if you want to see smoke better, or if you want to see less smoke in viewport, you can change this parameter. Then we have interpolation, and here we have 3 options: linear, cubic and closest. Linear, what this interpolation makes, it smooths out our smoke. Most optimal is linear one. In case if you use closest, it will turn off any smoothness. This will be looking like this one. This is the fastest option for preview, but you can't see very well all details. Cubic is the best for smoothing, but takes more time to calculate. So probably for viewport it doesn't matter much, but so linear is more optimal. You can see the difference. Becomes a little bit more smooth when you change this, but sometimes closest also works well. Usually I use linear option. And slice per voxel shows you this will work with closest. This will decrease quality of the smoke and will speed up calculations a little bit. So just for general shape of the smoke, this probably can be fine, but to make tweaks and understand how smoke looks like, it's not as good as it probably could be. Okay, let's get back to our settings tab. Here we have first domain type. Here we have 2 options, gas and liquid. As we are working with smoke, we need to pick gas. If we are going to work with liquid, we should pick liquid, of course. So let's leave it like gas. When we will switch to working with liquid, I'll explain this as well, but now we are working with smoke, so let's leave gas. Next moment is resolution division. Resolution division, to understand better how it works, let me explain you the structure of the domain. Here you can see small cube. This small cube is called voxel, and all our domain is divided into these small voxels. So right now we have 32 voxels here and here, and they make first row of voxels. And all this cube is divided into these invisible voxels. We don't see it, we just see this example how this voxel looks like. But in general it looks like this. This one is big one, let's make it smaller. I made this example just for preview purposes, so you can understand better what is voxel and the structure of the domain. This is very important to understand what is voxel, because a lot of parameters in Blender are based on this voxel, and we will use this grid later for some explanations. Let's make it fill our grid better. Okay, 32. Here we need to have 32 as well. Just approx like this. Okay, let's move it to the side so it will not be hiding our will not be hiding our smoke. So please keep in mind that all this domain is divided into voxels, and the voxel is small cubes, and Blender make calculation when smoke moves up. He switch to his calculation to the next voxel, next voxel, next voxel, and so on and so forth. So we do calculations in each voxel. So let's get back to our settings tab and resolution division. Right now we have 32 voxels here and 32 voxels here, and animation looks like this. In case if we make our resolution higher, for example 64, we will get smaller voxel. It will be more voxels here, and of course twice more voxels here. This will give us better quality simulation, but of course this will take more time to make all calculations inside of the domain. I also made rendered example how this can looks like in different options. This is how it looks like if you have 32 resolution division voxels, 64 and 128. Usually this is enough to have good quality smoke. Sometimes you need to make it even higher, but please keep in mind that higher resolution you make, the longer it will take to calculate it. Okay, so we already calculate. You can see the difference, how long it takes to make these calculations. But of course, definitely smoke looks much better now. You can see the difference. Okay, so we already discussed resolution division. Let's return it. Let's get it back to 32. Next option is timescale. What it makes? Timescale change speed of the smoke when it can be needed. For example, imagine volcano. You are staying somewhere and watching to the volcano that make explosion, and you see this smoke from far from this volcano. And when volcano make this explosion, it seems that smoke moves really slowly, but in real life, in real place, it moves really fast. But it looks like it's really slow. And to slow down it, you can make timescale slower. And in this case, it will be moving much slower. We almost don't see the motion, the movement of the smoke, but slowly moves up. And as we have dissolve here in 5 frames, it disappears really early. Let's turn it off to see better how timescale works. So we could see smoke moving higher. You can see that it moves really slowly, going up. Let's finish calculation to see it faster. So it works like this. I also made some calculations and rendering to present you how this timescale works, so you can see it here. You can see timescale 0.5, timescale 2, timescale 6. So 1 is just normal speed. If you made timescale equal to 2, it moves twice faster than normal speed. 6, it makes increased speed 6 times from normal speed. It moves much faster than usual speed. So normal speed is 1. That's how it moves. And here the same, if you make 6, you will see that it moves much faster. Boom. Okay, let's return it. Okay, it's done with timescale. Next moment is use adaptive time steps. Let's enable it. When we enable it, we get next option: CFL number, time step maximum and minimum. CFL number, it's current Frederick Lewis conditions mathematical term that is used here. What it makes, it's really cool stuff. To present you how it works, let's change our domain a little bit, like this, and let's animate our sphere, our emitter, our source. This will let us understand better how it works. Okay, like this. Let's disable this in viewport, so don't hide what we see here. Also, let's disable light for this moment. Oops, let's enable it. Let's reset our simulation. Okay, so what we see here, we see that we have some gaps. Blender makes we have really fast moving object here in our scene, and when it moves we have something like an error, or I don't know, some empty spaces between frames where we don't have any smoke, but in real life smoke should be here. We can fix it with few moments. So CFL number is important for quality of the calculation. It's responsible for quality of the calculations. So just imagine that you walk on a slippery road, and for example in 1 second you make, or in 2 seconds you make 4 steps. This means that it's your motion, your move is not stable, and you can fall down because road is slippery and you move really fast. But you move fast. In case if you need to cross, I don't know, 10 meters, you'll be really fast because you have 4 steps in 2 seconds. But you are not stable. In case if you will be doing just 1 step in this time, your motion, your movement will be much more stable and accurate. You will not fall down, or at least chance that you will fall down is much lower than when you do 4 steps in 1 second. CFL number has the same logic. The less number is here, the higher quality of the calculation will be. And this parameter increase quality in all domain, in full area of the domain. So just to see it better, you can, for example, let's decrease like this probably. And now you can see that we have less gaps here. We lost gaps here. We have 1 gap here, still have 1 gap. Let's make it even smaller. And now we don't have any gaps at all. That's it. We already almost don't have. Probably we need to change it even more. And yeah, smoke looks much better. But we should keep in mind that this really increase quality of the calculation in full area of the domain. Okay, so next moment is time step maximum. Maximum time steps mean how many additional divisions we get in between our frames. So when we had CFL number 2, we got these gaps, and these time steps maximum mean how many additional divisions calculation we get in these gaps. So maximum will be just 4. We can increase it, for example, to 8, and it will add even more. We will not see it right now because we have really high CFL number, but if we will make it small, we will increase this quality twice because we have here 8 and not 4. But mostly this will be enough. In case if you get really fast moving object, this can save your life because you can increase it here and that's it and working. Okay, Minimum, this is just simple. Minimum divisions, this is a basic, so 1 division per 1 period of time. That's what we see here. So you can play with these parameters to increase quality of the simulation, of your smoke simulation or other simulations. I can't not to mention about one more place where how you can increase quality of the simulation. This parameter is responsible for quality inside the domain, taking the full area of the domain. But we have one more parameter that can increase quality and a little bit more faster than that one. It's you can find it when you click on our source, on our emitter, and in settings tab you can see sampling substeps. Increasing these sampling substeps makes approximately the same what we had in domain with CFL, but this one is a little bit more faster. It works a little bit more faster. Why it works faster? Because CFL number increase quality and make calculation for full domain, but when we increase these subsampling steps here, it calculates only for emitted smoke. So when we do emission, let's return it back to 0. So we got these gaps again, and we say to our solver to double calculations. If you place here too, we say to double calculations only in this area, in between these voxels, in between these places where smoke was generated. So let's reset our simulation, subsampling steps, and take a look. Boom, it's done. So keep in mind that we have two places where we can play with quality of our simulation, but generally sometimes this can make some artifacts. For example, we can have some parts of the smoke jump into the different area, something like a bug, and you will not be able to fix it with this. To increase quality of the calculation, you should use CFL number. Just keep it in mind. Okay, let's return it back to 0, and let's switch to next parameter. Next parameter is our gravity. It's disabled right now here. It's disabled because we have it here enabled. If you disabled here, it will be enabled here. This is, you can use it if you have different domains. For example, if you have two domains, and here I want to have these settings set up for gravity, and for example in this domain I want to have different setup for the gravity. So you can use it in this case for different domains. Let's return it back. So gravity is enabled. Okay, so gravity, empty space. Let's talk about empty space. So we need to get back our voxel structure, and let's place it here just for some preview purposes, and let's calculate our simulation one more time. Probably I'll change simulation animation a little bit. I'll place our sphere here, I'll add key, then I'll move it here, and we'll add one more key. So yeah, oops, we need to reset our animation. Okay, it's reset it, and let's simulate it. Okay, done. Okay, let's, to make it more smooth and more interesting, I'll add initial velocity. This will help me to explain you better what is empty space in domain. And let's add some sampling substeps. So maybe let's try with 0 first, and then see if we need to increase it. Yeah, probably we need to increase it. We need to reset it because initial velocity do not work yet. Yeah, it works. Initial velocity works, And also, to explain you better, we probably need to enable dissolve option, maybe 7 frames. Let's take a look how it looks like now. Yes, it's fine. And let's cover more. Let's add more. Oh, grid big. Let's make bigger grid here. Okay. Okay. So what empty space do? We see this approx. Okay, it has changed. Let's make it more close to what we have here. So our domain size is approx like this. Our voxel size is like this. It's again big, too big. Let's make it smaller. And this one is responsible for z-axis. Okay. Okay, so now visually we can see with this voxel size. This is approximately how our voxels are looks like in inside of our domain. And when we click on domain, let's get back to empty space. Empty space. It analyzes each voxel and density of the smoke inside of this voxel. Let's make it visually more dense, so it will be better to see. It will be easier to see for us what we have. Just like this. So Blender analyzes each voxel and how much smoke we have inside of this voxel. If density of the smoke will be lower than this parameter, Blender will not be doing any calculations of the smoke here. So this voxel will be empty. If density of the smoke will be higher on this parameter, Blender will be calculating this parameter here. Maybe this will be a bit more clear. No, probably I'll use cubic. Okay. Visually, actually, it's not visible on preview to see the difference of this parameter. I'll make two different setups so you will be able to compare how it looks like. Okay, so let's bake it. Let's go to cache, use all. So we need to bake all parameters that we have here and click bake. Okay, done. Let's make one more domain. This domain will use these VDB files that we already baked. And for this domain, I'm going to use another folder. Test cache. Let's not accurate. Let's make it test cache 2. This is second folder, accept. Okay, free all. Let's change empty space. Let's try like this. Let's create bake. You can see the difference in this simulation. When density of the smoke becomes less than we have in empty space, it do not any calculations anymore in this voxel. And here we still have this smoke. Thus that can make pretty funny effect. So you can use dissolve option. Also you can use empty space option to remove some smoke. And of course this will make calculation faster because, for example, here we still do calculations of the smoke in these voxels, but here in these spaces, in these areas, we already do not make any calculations anymore. So this calculation will be faster. Okay, Let's keep moving farther. Okay, let's remove it. Let's delete our bake and switch back to preview in viewport. Okay, what is our next parameter? Delete in obstacles. In some reasons I do not found how to make it working. The main logic is, let's remove our voxel grid. The main logic is that if you have any obstacle here, okay, let's simulate it one more time. When you have any obstacle, you shouldn't do any calculation inside of the obstacle. And I don't know how to make it work in some reasons. Seems like a bug. So I don't know if it's not working. Anyway, if you want to remove smoke inside of the obstacle, you can use another option. You can choose your obstacle, click fluid, and click here effector. And when you will use this, okay, let's reset it. This will not be calculating smoke inside of the obstacle. Okay, probably not the best obstacle. Maybe if we use cylinder, you will see it better. Scale, and let's assign to it a factor. Let's make it visible like a wire. Okay, and so you can see that Blender do not calculate smoke inside of the obstacle. Actually, I'll cover all these options later as well, so just keep it right now. Just keep in mind that we have this option. Okay, we also need to return empty space to our original. Let's reset our simulation. Let's calculate it again. Okay, great. Okay, let's remove this obstacle for now. Okay, next option. Let's take a look what we have. Let's remove it. Body collisions. We have few checkbox here. Let's update our visual part. Let's change this. Let's make like this. Okay. Okay, so now when we do simulation, our smoke moves up, and when it hit upper edge, it still keep moving somewhere higher, but we don't see it because it's cutted by our upper edge. We also don't have any walls at all on any sides. It's not limited by anything right now. It's limited only by size of the domain. But if we want to limit it by something, so for example we want to make it like invisible sailing, we can enable front checkbox. Oops, not front but top checkbox, and we will make it colliding with our sailing. Now it collides and we see this smoke, but as we don't have any walls on the sides, you can see it now that it collides and moves here like it's obstacle here. But as we don't have any walls on the sides, it still go away from this area. If we still want to keep it inside of the box, we can add other walls. And in this case, the smoke will not leave this area. We still have nothing on the bottom. It goes down right now. You can see it. So we can fill our domain with smoke if we enable all these checkboxes. Okay, So, and last option is in settings tab is adaptive domain. This is pretty cool feature. If you enable it, to make it more understandable, let's place it like here, so we can see with x-axis where is our upper edge of the domain. It's somewhere in 0 on z-axis 0. Okay, so when we start our simulation and when we reach, let's disable it for a moment. When we start our simulation and when our smoke reach our upper edge, we don't do any calculations that possibly could be higher above this line. And still we do a lot of calculation inside in full area of the domain, even if we don't have any smoke somewhere. For example, if our domain will be like this, let's recalculate it. We still take some PC capacities to calculate it even here. So you always should keep in mind that our domain shouldn't be much bigger than our simulation, just to save some PC capacities. Let's reset our... And what adaptive domain provide us? Our domain becomes adaptive. It starts calculations only in areas where it's needed. You can see that it change its size, but when it reach original size of domain, it stops. If you want to make it moving even higher, we can add resolution. If we will place here, for example, number 4, this will add 4 more voxels above when smoke reach this level. So let's take a look how it works. Let's reset our simulation. Goes like this. This will reach our... Yes. And then it goes 4 more voxels. Please take a look. This is voxel size. And approximately 4 voxels more we got here. So this will let us, if we'll place here 10, we'll get 10 more voxels higher if it will be needed. Yeah, we got it. Okay, cool. What is margin? Okay, so to make it faster, I'll maybe add just 2. What is margin? Margin is a distance between smoke and between our upper edge. This is like a safe area for us, because if smoke will be moving really fast, for example, if smoke moves in one frame for huge distance because of the speed or gravity or some other setups or settings, we can get cut off of our smoke, and that will be not good for our project, for our animation. So we always should keep in mind that where is this upper edge. In case if we disable, you will get this sharp line here. This is not good. And to prevent it, to get some safe area, in case of fast moving smoke, we can increase this margin. For example, it can be 8, twice bigger. Now it's twice bigger than it was before, and we have more space. So if in one frame smoke will make movement higher, it will not be cut by this edge, or even bigger, maybe like 15. We have a lot of space here right now for calculations. But of course, when we reach upper level, it stops. And of course, it will be cut here. Okay, so let's get it back to 4 and probably the resolution to 0. And let's resimulate it again. Okay, simulation is moving. And last one parameter is threshold. What this parameter makes? As we already discussed with you, as we already seen with you, we have margin. This margin is equal to this voxel, so we have approximately 4 voxels. And this threshold, let's retain our voxels grid. Oops. Let's place it here. Where is our domain? Let's recalculate it. Okay, something like this. Let's make, to make it more understandable, I'll make this cube smaller. Approximately of the size should be approximately like of the voxel. So what it makes, what threshold makes? Blender makes calculation of the density of the smoke in each voxel. Let's go back a little bit, like this. For example, we see this voxel, it's partially filled with smoke, approximately less than 1/2, and second half is not filled with smoke. So Blender makes calculation of what is the density of the smoke in this voxel, and this, and this, and this, and if the density of the smoke will be higher than this parameter. We have 1, 2, 3, 4. We have 4 voxels here, margin, and when density of the smoke will be higher in this voxel, size of the domain will be changed for 1 voxel higher. You can see that, yeah, you can see that domain change its sizes. And this parameter helps Blender to calculate when domain should be changed. So if your threshold will be very slow, like this, domain will be really sensitive. So if small amount of smoke will be inside of the voxel, this will let Blender know that it should change domain size and make it higher. It will be more sensitive for small calculation, but of course this will take some more time to calculate it. If this threshold will be very low, I don't know, maybe like this, for example, it will be not very sensitive, and in some moment it's not visible here. Let's even higher parameter. In some moment you can see here we have margin 4, but threshold is really high, so Blender think that, for example, here density is not enough here and not enough here, still is not enough here to change domain size, and it's not change size of the domain. But on the next frame, source emitted a little bit more smoke, and Blender understood that we have density higher than this, and it adds some height for the domain. This makes calculation probably a little bit faster, but you can get some cutoffs like here. We do not reach our upper level yet, but we already got some cutoffs. We can play with margin in this case probably. Let's try it and see what we get. So we'll get the safe area to prevent, yeah, we don't get any, but still we got it here. So yeah, probably we should have even more margin. Anyway, I think you understood how threshold works. Just one more example about domain, when it can be used, this option, when this adaptive domain option can be used. For example, we can use, let's make domain bigger to see it better, like this. Let's make it scale. Let's take our object here. Let's add key and animate it here. Oops, I forgot to here, and let's add key here. Let's hide this. Okay, and let's animate. Okay, so let's change margin to 4, and if you make one more simulation like this with adaptive domain, you can see that domain changes size in the end, and this is really useful option. You don't need to calculate anymore. We still have some smoke here. It's not visible in viewport, but still Blender makes some calculations here in domain, and we don't do these calculations anymore because density of the smoke becomes smaller. and sometimes it can be really useful for your projects. That's it for now. In next tutorial I'm going to talk about other options like gas section, and probably I'll cover some more options here. Thank you for watching and take care.